firm, presenting the Mini and the Worm for POE. So design brief here. We're making it for the city of Harmonia. I am the lead engineer, and we were trying to provide different options of bridges for the city of Harmonia through engineeringu.com that can get a car across without braking and can be modeled by West Point Bridge Designer. The first one is the Worm, and it is titled thusly because you'll notice that the different types of steel allow it to curve like this, which we think would be very interesting to watch for the children of Harmonia. It would get them interested in physics, it would get them interested in engineering and design, and it will be very similar to most roller coasters where you kind of fear for your life just a little bit. I think that it would be excellent if a school bus perhaps, if a school bus was the same weight as this truck, you could go down and have some swoops, and the children would maybe enjoy going to school a little bit more. So the design, as you can see up here, we used a lot of different types of steel, and we used some very thin joints over here so that it would have dips at the ends here where children wouldn't expect. Usually kids would expect the dip to be in the middle, but it's not, because that's too easy. So we had the dips being on both sides so that the kids won't expect it and will maybe stop eating on the bus because they keep spilling things. So finances for this bridge, it was kind of expensive. We used a lot of different parts, and a lot of them are very long, and we had to use all sorts of different, the most expensive steel for some of them. We thought that tempered steel would have a little more stretch to it and allow the bridge to bend. That was the idea there, and then having it thinner would also allow it to have a little bit more give to it. So so this bridge did cost a bit more, and here is the actual information for each member. It's not terribly efficient. There's a lot of members here. As you can see, like member 3 had 0 strain for tension and compression, so it was not optimized, but it was a very fun ride.
What was the price again?
250,000 something. Oh no, it's at least 300,000. It looks like it got cut off. Oops. That's my bad. Okay, this is the Mini. This is a bridge designed to have a fun-sized bridge that is much, much smaller. So most of the cost of this is excavating all the way down to the minimum height, and then we tried to have each bar be under maximum tension or compression. And for some of these, it actually goes under both. It goes very green and very blue and very red. So there's a lot of strain on all of them, and we used hollow tube for the parts that went under compression because we figured that that would be the most, it'd be able to, for the money, be able to take the most compression, whereas these, which were mostly under tension, we had solid bar, and we had mostly high strength, low alloy steel, and then 1 bar of quenched and tempered steel, because, I don't know, it worked for some reason. And so this is the finances here. Again, for some reason, the total has been taken off, but it's 177,061.43, I think. I'm not sure on the cents, but it was definitely 177,061 something. And so...
So your fun bridge costs less than your...
No, the fun bridge cost like...
The fun bridge was your first one,
Yeah, this is the cheap bridge.
Okay, that's why I was confused.
And this bridge was very well optimized with each member taking quite a bit of strain. If a truck weighed just a little bit more, it would probably break this, but luckily we have identical trucks going across here one at a time, waiting their turn very nicely in this city. So that's very convenient. And yeah, that's this bridge. It was pretty cheap.